All right, so there was a homework assignment for P3. I didn't collect it, right? I'm not going to ask you to hand it in. Are there any questions about any of those problems? Yes. Sure. So what I'll do is if there's any homework questions, I'll just put it at the end of the section notes. That way, like, you all have it to look at. All right, so this is number 47. All right, so this is just perform the indicated operations. Okay, so we have this guy here. All right, so what we want to do here is we want to go ahead and do the left side first because we can't do the subtraction yet, right? Because x plus 2 is acting like its own variable in this problem, so we can't subtract the x squared yet. So what you have to do is basically just work on this part here. So if you remember, anytime you see, a term, this is a binomial, right? Just two terms, and it's squared. You could separate it like this. So that, doesn't change anything with that minus x squared. Now you do this indicated FOIL right here. So you'll get x squared. And now this is one of those ones where the inner term is 2x and the outer term is the same. And then you do the last terms are 4. Now once you're here, since you have only addition and subtraction, the order of operations say you could do any of them in any order, really. So you could take the 2x squareds here are going to cancel out, right? You're basically going to have x squared minus x squared and get 0. And then the only thing that's left would be to add the two x's, and then the 4 is by itself. So that would be your final answer there. Okay. Who just came in the back there? I just want to... Liam, got it. Thank you. I'll get all the names at some point. It's just still pretty early. Okay. Any other questions on the homework that I could go over? What do you got?
Like number 79, where there's two variables.
Yes.
And then the term with x and y.
Yep.
Is like in the center.
Yep.
In the book, they have it like the answer being 3x squared plus 11xy plus 10y squared.
I don't care about the order.
Either you don't care.
No, it doesn't matter to me. Okay. Yeah. I mean, they have what they call a standard form. I think all the instructions say standard form. To be honest, to me, it doesn't matter. Okay. So whichever order. So did you need to see that, or is that okay? Because I could even just do this. She's asking a problem just like this, right? Where I put the xy term at the end, right? I don't care if he had it in the middle or not, whatever. It's fine. Doesn't matter to me. Okay. Any other questions? Yes, sir.
What if there's one like that? It's like just like 15a squared. Should you put that up there with like the 10x squared or something like that?
Like if you had an a, yeah, I mean the order I don't care. So like if you had an a square, like we just use, I don't know why the book chooses x. I don't know what the history is behind that, but like if there's a's and b's, I don't care if the b's first or the a's first. It doesn't matter to me. I'm just looking for, are the terms correct, and are the signs on the terms correct? That's all that matters for me. Okay. Any other questions on the homework? Okay, so what we'll do is we'll do that quiz at the end. I'll give you some more instructions on that. But for right now, we're going to move right back into section P4. So just a quick review about what we did in that section. So it was all about factoring polynomials. So in order to do that, you have to be able to determine something called the greatest common factor. Tika, that was you that just came in, right? I just want to make sure I'm taking roll, just in case they have to do contact tracing. There's no penalty if you're late, by the way. Just, not that I want you to be late, but, it happens. Okay, so you have to find something called the greatest common factor. So we just define that as this term that I have written down here, ax to the n. So a is going to be the greatest integer that divides all of the terms in your polynomial, and then n is the least exponent of whichever variable you're looking at. So I have exponent of x just because we always use, x is the variable. So I just gave you some simple examples, and this was definitely a review, I think, where you have two terms, find the GCF, and then just figure out what you have to multiply that GCF by to get each of those terms. Okay? So any questions on how to do just like something like that? It's pretty Pretty simple and basic. We've all done that before. Okay. Next thing was, all right, so now you have a quadratic polynomial, which means the degree of the variable is 2. All right. So how do you factor something that looks like x squared? So when you have, a term like x squared with no coefficient in front, really the coefficient's 1. So we just are looking at these at the beginning. So you have x squared plus bx, where b is a coefficient, and then plus c, where c is another coefficient. So how do you go about figuring out how to solve that? So we had a little process here, right? So you look for a times b. All right, so this is basically 2 factors of the coefficient c, such that when you add them together, you get the b term. So here's the example, right? X squared minus 6x minus 16. We found the factors of 16, wrote them all out. 8 times 2, 4 times 4, 16 times 1. How could you make 6 out of any of those factors? So you can't do anything with 16, 1. You can't do anything with 4 and 4. But 8 and 2, you can get 6 by doing 8 minus 2. So that's how you knew to put 8 and 2 here. And then you had to make sure you get a minus 6 here. So the 8 was negative, and then the 2 was positive. Okay? So any questions on those? We're okay with those? And we're going to use this process another time today. What happens if that coefficient in front of the x is not a 1? And then the last thing we talked about were perfect squares. So if you can pick these out, it becomes easier to solve the problem. So this is now when you have another quadratic polynomial. These are trinomials because they have 3 terms. If you could pick out this term here, figure out what its square root is, right? So it would be x, and then the square root of 4 here would be 2. If it just so happens that you have each of those square roots in your 2 binomials, you can combine those to be an x plus 2 squared. All right, so that's a perfect square if you could pick it out when you look at your polynomials. So there's another special case called, and this will be the start of new stuff today, it's a difference of squares. By the way, I'm going to be trying to check time. So I want to give you 20 minutes for the quiz. I think that's plenty of time. So that means I want you to have the quiz at 9:25. So if you see me getting close to 9:20 and I seem to be still going strong, ask me to stop, right? So I can give you some instructions about the quiz so everyone's clear about how that's going to work. Okay? All right. So difference of squares. So say you had something like this. X squared minus 49, and you wanted to see if you could factor that. All right, so when you take the square root of a number, if you get an integer, okay, you're able to do a difference of squares. So you look at the 2 terms. When you take the square root of x squared, you get x. And when you take the square root of 49, you get 7. All right, so that's all what that means is difference between squares. So how could you factor this? You put your x term here, right? Square root of x squared is going to give you x, so that goes at the beginning of each binomial. And then the square root of 49 is 7, that goes here. Now the only difference is, in order to get 49 to be negative, the signs on 7 have to be different. Now it doesn't matter if you have the x minus 7 first or the x plus 7 first, it doesn't matter. Okay, so these are kind of simple. Now you can have ones like this where the coefficient in front of x squared is not 1, but it's still possible. What's the square root of 9x squared? Just as an aside over here, right? If you do the square root, and what's interesting is there's a whole, I think it's section P6, well, maybe it's a little bit in P7, or I'm sorry, P5. They talk about how to do this, but they're assuming you could do it in this section, which is weird. There's a lot of weird things about the review. So what does that equal? What could you do? Are you allowed to do this? Can you separate? Is that allowed? Yeah, you can. You can separate them like that. And then we all know the square root of 9 is 3. And then again, the square root of x squared is x. Okay, so that's good. And then we know we could take the square root of 16 and get 4. So you'll have your 3x's here, your 4's here, and again, the signs are just opposite. So that 16's negative. just one more example. Now these tend to be easy to pick out because they only have two terms. I think everything that we've done so far, aside from maybe these ones at the beginning, but like, you can't take the square root of 24, right? In this example, can't do that. So, that's not going to be, and it's one thing, it's a positive number. Same thing here, you can't take the square root of 18. So if you're having two terms, you're most likely just factoring out a greatest common factor. But if you have the difference like this, and you could pick out that they're square roots, you could take the square roots of both terms. These are easy to find, on a quiz or exam. So what's the square root of 25x squared? You'd get a 5x, right? Square root of 25 is 5, and then square root of x squared is x. And then 81 is, you get 9, and then you just throw the different signs there. Okay? Okie doke. So far, so good? Remember, you got to yell at me if I can't see you over there. All right, they're pretty easy to pick out. All right, now, people, I'm just going to let you know right now, the next couple things tend to trip people up. But again, they're easy to pick out on quizzes and exams because the next type of factoring is called factoring by grouping. And factoring by grouping, you're essentially always going to see four terms. So I don't know if two terms in a polynomial are a binomial, three is a trinomial. I don't know if this is a polynomial, quadronial. I don't know if that's actually a thing, but it's got four terms. Okay, so something like this. Pick a good one out here. Yeah, this will be good. Say you had 6x cubed minus 3x squared minus 4x plus 2. Okay. So what's the greatest common factor for this polynomial? It's 1, right? So you really can't factor anything out, right, if your GCF is 1. So what do? So what you do is you look at groups within the polynomial. So specifically, let's first look at this group right here. 6x cubed minus 3x squared. Does that have a GCF? What would it be?
3.
So it's 3. So that's the coefficient. Now what's the lowest term, the lowest degree of x? X squared. All right, so now let's factor just those two terms with that GCF. What do we get? So what do you multiply 3x squared by to get 6x cubed? It's a 2 to get the 6, and then an x to get the x cubed. All right, and then minus, so this is an easy one. What do you multiply 3x squared by to get 3x squared? 1. All right, so then now we have this term, 2x minus 1. All right, now you repeat that same process with the next grouping. So what's the GCF of that group? It's a 2. Now what I'm going to do is I'm going to try to put a plus 2 or a minus 2. So sometimes you have to just play with it. I'm going to throw a minus 2 in there and see what happens. Right? Okay, so what do you multiply minus 2 by to get? Should be negative 2, sorry, times, what do you multiply negative 2 by to get negative 4x? Now what should happen is you should start to see this exact same factor again. Right? So negative 2 times 2x is negative 4x. And then how do I get plus 2 with a negative 2? So I have to multiply negative 2 by negative 1 to get a positive 2, right? All right, so now do you see that there's two terms now, right? We went from 4 terms to 2 terms. Now do you see that each of those 2 terms, like I just want to make sure like you understand like how this works. So here's term 1 and here's term 2, right? It would be sort of like having I'm just going to make a real easy example. Like here's 2 terms, right? Here's term 1, here's term 2, and you're factoring out something from both of those terms. So what's common between term 1 and term 2? Isn't it that 2x minus 1 term? So you throw that sucker first, and then what goes in the next binomial is just the terms in front of those terms. The terms in front of the 2x minus 1 terms, which would be 3x squared, and then you keep that minus sign, minus 2. I'm going to do a couple of these, and you're going to see these come up in other processes in this section, right? So that's factoring by grouping. So you can't factor all 4 at once, but you do them in pairs. Now, sometimes when you get to this point, now it won't happen in this problem, sometimes you can then factor the binomials. But can you factor any of these binomials? Is 2x minus 1 fully factored? It is, yep. And how about 3x squared minus 2? Yeah, fully factored, right? Because we're only factoring out integers. All right, so that's example 1. All right, let's do another one. And again, easy to pick out because they have 4 terms. So this is kind of, every time I say something like that, like these are easy to pick out, I'm sort of trying to give you some exam and quiz strategies for when you study. Right, this math class is all about showing you how to do different mathematical processes so that when you get to, I don't know, maybe your business classes or wherever, whatever your major is, you can use some of those processes. So when you take a quiz or exam in this class, you know, when you're studying, you're going to find that there's categories of problems, right? So I'm just making up a number. Maybe there's 10 different types of problems or categories of problems for the first exam, just as I'm using 10 as an example. Maybe 7 of them you could do without even thinking. They're so easy for you, boom, you're done. Well, then you probably don't have to study those as much, right? You could focus on the 3 categories that trip you up, okay? So that's why every time I do a problem, I'm going, oh, these are easy to pick out because there's 4 terms, right? So this is sort of a category, all right? All right, same deal here, 4 terms. The GCF is 1. Can't factor it anymore. So sometimes you have to maybe maneuver some of the terms within the polynomial to factor it. But most of the time, the book's nice, and I'm pretty nice when I do problems. You probably just have to look at the first pair, find the GCF. So what's the GCF of x cubed plus 5x squared? It's just x squared, right? Because 1 would be the integer, but we don't put a 1 there. And then the lowest degree is 2, so we have x squared. And then what do you multiply x squared by to get x cubed? You get an x. And then the second term just is a plus 5, right? Cool. Okay, now you do the next thing. Now, this one's, it's not tricky. There's just plus. Now, what's the GCF of x plus 5? It's 1, right? But do I want to put a 1 here? You could, in this case, right? So, because you don't want to, because this one's going to show up in the final answer, right? So I'll show you that in a second. So what do you multiply 1 by to get x? X. What do you multiply 1 by to get 5? Plus 5. So you see that your common term, instead of going from 4 terms, you're now at 2 terms. What's the common term? X plus 5. So that goes out front here. And then finally, what's left? Well, this is why I left that 1 there, even though I probably didn't have to have it there. Now I know the next term is x squared plus 1. So I didn't want to lose track of that 1, so I kept it in this case. Okay. So just be careful for those 1s. You don't want to lose it. All right, I'm just going to give you another example of factor by grouping. And then we're actually going to see that we're going to use it in other problems. All right, so here it is. It's kind of long, and we have large degrees here. So 3x to the 7th plus x to the 4th plus 3x to the 5th plus x squared. Okay. Again, what's the GCF of that? 3x to the 7th plus x to the 4th. Integer's 1, and then the lowest degree is 4. So we're going to take out a 4, x to the 4th. Then I multiply what times x to the 4th to get 3x to the 7th? Well, I'm definitely going to have a 3, and I'm going to have an x to the 3rd. Does everyone agree with that? right? You're checking my work just to make sure I don't make a mistake, and then I'm doing plus 1. Yes?
Should you rewrite it to the exponent in order? Like 3x to the 7 plus 3x to the 4.
Okay, so I don't know where I got this problem from. By the way, a lot of the examples I do are just even problems at the end of the section. They probably put it this way because they want you to factor the 3x to the 7th and the x to the 4th.
Okay.
That's probably why. So if they give it to you in that order, just that's fine. Yeah. So we'll see. Let's factor the next one. Again, the integer's 1, and then the lowest power of x is 2. And then you look what we get. We get a 3x cubed plus 1. So, Kaylee, that would be y, because it worked out nice, you know. And actually, some of these, and I'm not sure if it's all of them, even if these were scrambled around the terms in the original polynomial, it'll still work. You'll still be able to factor it. So really, the order in these aren't really that important. Okay, so let's finish this one off. So we have 3x cubed plus 1, and then x to the 4th plus x squared. Okay. So here's the question now. Can I factor 3x cubed plus 1 anymore? No. How about the x 4th plus x squared? Can't I? Doesn't that have a GCF? What would be the greatest common factor of x to the 4th plus x squared? X squared. So here's what I'm going to do. Now I'm going to rewrite it like this just because the term's on the right. I'm going to throw the x squared out here. And then we have x squared plus 1. All right. Now, do we want to leave that as the final answer? No. We definitely don't want to do that. What we want to do is if we have binomials, right, we have two binomials here, right, the 3x squared plus 1 and the x squared plus 1. We want to have the binomials after any single terms. So the x squared is a single term. So I'm just going to move that bad boy out front here. And then which one you put next doesn't matter. And then just ask yourself, can you factor x squared plus 1? You cannot. Okay? So that's it. That one's done. So just be aware when you're factored by grouping, at the end, ask yourself, can I factor those two binomials any further? Okay. Okay. All right, so here we go. We're going to end up using factored by grouping now. First off, just any other questions on that? We're okay? Awesome. Somebody just came in too. I just want to mark that you're here. Didn't somebody come in? Oh, maybe somebody went to their lavatory and came. Sorry. Didn't mean to point you out. Okay. Perfect. So here we're going to do more factoring. All right, so we're going to factoring of this form. It's sort of what we kind of started with at the beginning. Remember, we had the 1x squared plus bx plus c. But now, what happens when there's a coefficient in front of x squared? You know, how do you factor something like this? So here's the first example. No, I'll be honest. So I don't know. I probably took algebra in 8th or 9th grade. So that would be like 1997 or something, right? So that's like is that over 20 years ago? Yeah, over 20 years ago when I first learned how to do this. And there really wasn't a good method. Like, I don't know how you learned it in high school, but this is literally like, they basically told us to do it by trial and error. I mean, I swear to God, they were like, well, you just go over here and say, well, all right, 6x squared. Well, first off, you know the 7, you got one of these, it's got to be a 7 and a 1, and then you just guess, well, is this going to be a 6x and an x? And oh, that doesn't work. You know what I mean? They just had you sort of like flounder around trying to figure it out. At least that's what I remember from my experience. And maybe I just had a terrible teacher when I first learned this. So this is what you do. You're going to identify A and C, the capital A and the capital C here. So A is 6, and then C is 7. Right? And what you're going to do is you're going to multiply those together. So you're going to do A times C, so 6 times 7. And again, I'm not expecting you to write all of it out, although if you did, and I found a small error, that'd be less points off than if you just, gave me a final answer. So 6 times 7 is 42. All right. Now that you have 42, you find the factors of 42. So help me out. I want all of them. What are the factors of 42? Well, 42 and 1, I'll give you an easy one. How about 21 and 2? Will that do it? Yep. What else? 7 and 6? Obviously. Anything else? And 14 and 3, and I think that might be it. Okay? Okay, so now that you have those factors, now it's sort of just like the other method. Now that we have those factors, you're going to see, you see the middle term here? 17x? Looking at those factors, how can I make 17? Or can I do anything to those to make them 17? Yeah. Yeah, so this is what you do. You're going to expand, you're going to change 17x to look like this. So we're going to keep the 6x squared, that's going to be there. And then instead of having 17x, you're going to put a 14 and a 3x. Now how you do that depends on the sign on the 17x. So it's a positive 17x, which means we're just going to add 14 and 3. So what I'm going to do is I'm going to do plus, now here's where you have to sort of think about this. I'm going to do the 3x first plus 14x, right? So that this 3x plus 14x came from 17x, and then I'm going to tag the 7 on the end. So why do you think I put the 3x first? What was I thinking about in my head?
6.
Yeah, like 6 doesn't go into 14, right? Because you see that now that we have 4 terms, what are we going to do? We're going to factor by grouping, okay? So I thought to myself in my head, well, I'm not going to be able to factor that 14 in the 6. I mean, I could take a 2 out, right? But then I'm going to have to refactor that final binomial. So by putting the 6 in the 3, I know they divide evenly, so I thought, well, I'll put that one first and roll the dice and see what happens. Okay, awesome. Now we're at this point. Now we just repeat what we've been doing before. Now we have these two. What's the GCF of 6x squared plus 3x? It's a 3 and x, right? And then what do we multiply 3x by to get 6x squared? It's going to be a 2x. And then a plus 1, right? 3x times 1 is going to give me that 3x. Perfect. And now we're looking at the second pair. What could I take out of that one? 7. Now what's the lowest degree of x there? I want to, because I've seen people trip up on this before. Doesn't look like, well, x is the lowest term, right? Here's the tricky thing. If you have a coefficient, what's there is an x to the 0, right? What's x to the 0? Actually, what's anything to the 0 power? 1. So that's where you got to be careful. If you only see an x there, you don't want to bring that down as part of being the factor. You got to assume that the coefficient has an x to the 0. So an x to the 0 would be the lowest degree. And then what do we have left? Well, 7 times 2x gives me 14x, and then plus 1 to get me 7. So there you go. Now you have the same exact process as before. We have our 2x plus 1, and then our 3x plus 7. Boom. Can you factor those any further? Nope. No, you cannot. Yeah. I wish I learned that because I swear to God that never happened. I don't even remember factor by grouping. Okay, and I really thought I had good math teachers. All right, here's another one. By the way, in math, science, any types of problem solving, the only way you get good at them is if you just practice them over and over again. So here's another one. And I like to give a lot of examples. I know there's a lot of math professors on campus who like to talk more about like, oh, well, this is why, blah, blah, blah. Look, you guys are in this class because you need to know how to do some of this stuff. So that's why we're doing it. Okie dokie. So, all right, we need to determine A and C. And I'm going to always try to talk through my thought process as I go. So I got to get A and C. So A is 2, C is 27. So 2 times 27 is going to give me 54, right? And by the way, like say this isn't going to be on the quiz today, this stuff, but say your mind's blanking on the quiz because some people obviously get a little anxiety and stuff. Like you are allowed to have a calculator, so don't feel bad if you had to do 2 times 27 just to get that number. Don't worry about it. Sometimes I'll brain fart up here and have to do it myself. All right, so 54. What are the factors of 54? You always get 54 and 1, and then you can always probably, if it's even, divide it by 2. So that's, I think, a 27 and 2. Is that true? Yeah, I think so. Right? What else? 9 and 6. Is it, no, not 12. 11, no. Is there anything else? I think that's it. It's got to be a 3. 3 divided by that, what is that? 20. No, I think that might be it. I knew there was another one. But we didn't even need that one, but I knew there had to be another one. Okay, so if you look at the middle term is 3x, positive 3x. Can I get that from any of these factors? Yeah, I can get it from the 9 and 6. All right, so I'm going to leave my 2x squared out front. Now, I got to get a positive 3x, which means which one of the, I can't add 9 and 6. Like I can't put plus 9 plus 6, right? I have to have one of them positive, one of them negative, right? So which one's going to be positive? It's going to be the larger term, right? So we're going to put, now again, do I want to put that 9 with the 2? Probably not, but I could put the 6 over there. So I'm going to do minus 6x plus 9x, right? I did that from this 3x, and then the minus 27. So do you see why I put the 6 where I put it? Right? Yeah, good. Now it's factor by grouping. All right, GCF of that sucker, we got a 2 and an x, and we're left with x minus 3.
Why did you choose the 6 and 9 opposed to any of the other ones?
Oh, like what? Let's say, why didn't I choose 27 and 2?
Yeah.
If I add 27 and 2 or subtract them, could I ever get 3? Can I do that with 18? Does that make sense? Yeah. So there's really only one set of factors that's going to be the one to do, all right? I don't think I've ran into one. No, it's only going to be one set of them, okay? It's a good question, though. So I have my 2x times that x minus 3. And then out of these other ones, I'm probably going to take out a 9. Yep, can't take out an x. And then we have x minus 3. And then combine everything here. And then just do a final check to see if I could factor those anymore, and I cannot. Okay. They're okay, right? They don't seem too bad. Any questions on those? All right, so there's one more factoring topic from this section, and then we'll put P4 to bed here. Okay, now I do remember this from back in the 20 years ago. So we're going to factor, and this was probably the most less enjoyable than most things. And I like math. I minored in math here. By the way, I'm an alumnus. Did I tell you that? I graduated from here, so I have a minor in math. And this is fine. I'll just, once I write all this out. So it's factored by making and this is the part you probably remember, a perfect square. Factoring by making a perfect square. All right, so let me just write out a polynomial, and I'll show you the process. All right, so something like this. So you can't factor by grouping. Right? You're missing a term. Right? It's a tough one, right? You're not really sure what to do with this one. Okay, so what you have to do, and just to be honest with you, so when I graduated from here, I immediately wanted to teach, but I couldn't find a teaching job immediately in physics and math. So I went to work as an engineer for Lockheed Martin down in King of Prussia. Then I came back, taught a little bit here as like an adjunct and things, but then I eventually went to Florida. I actually lived on an island in Florida, and you might be asking yourself, why are you back here in Scranton? That's a good question. But anyway, when I was down there, I taught a course for basically the National Security Agency, doing a bunch of different things. And I've never once in my life used this, right? I always tell that story just because, like, I wonder why they have it here. Like, you're all going to have to tell me, you know, your 4 years here at Scranton. Tell me at any point, did you use this method? Because if you haven't, I'm probably not going to teach it anymore, right? Because why waste your, you know what I'm saying? Like, why waste your time on something? Like, I want you to, you know, leave here with useful things you can use in other classes, but I don't know, man, I haven't used this ever. Aside from, you know, taking it when I was a kid and doing it right now with you. So here's what you do. Can't do anything with this. So you look at the first term and the last term, and you take their square roots. So what's the square roots there? Square root of x to the fourth? X squared. And how about the 1? 1, right? All right. So there you go. I put a plus there just because everything else in there is plus. So here's what you do. You take those square roots, and then you make this term over here. So this term over here isn't a part of the problem just yet, but you want to go ahead and evaluate it. And what do you get? You get x to the fourth. Well, here, I'll even write it out the way we were doing it before. Right? Can't I rewrite it like that? That becomes a little easier to do. So you have x to the, because we're just going to FOIL it. X to the fourth plus x squared plus 1. So then we have that being x to the fourth plus 2x squared plus 1. So do you see how that's close to the thing that we're working with? Okay. It's close. So what I want to do is I want to try to get this guy to show up over here. And again, what you're going to do is you're going to mess with that middle term. So you keep the x to the fourth. Now, how can I introduce a 2x squared into this problem? Like, how can I change this x squared? Could I do this? Anyone want to give it a shot, though? Just in case I didn't see a hand. Yeah. Well, plus x isn't going to make it x squared. Well, they're both going to have x squared in it. So I'll show you what I would do. I would change this x squared over here, right, to this. And once you see it, it'll be like, oh, okay. Can I do, because I have to introduce the 2x squared, and then can I just say, well, 2x squared minus x squared gets me a positive x squared, right? Does everyone see that? Right? And then I still have the plus 1 at the end. Okay? So now you're thinking to yourself, okay, I'm going to factor by grouping. But here's what I'm going to do. I'm going to rearrange this a little bit, and I'm going to put x to the fourth plus 2x squared plus 1 minus x squared. Okay? So do you see that this thing over here, right, this guy, is now right here. And we already know this thing looks like this piece. So x squared plus 1 squared, right? That we already know that's how you factor that. And then minus x squared. Now, what does that line look like to you? Isn't that the difference between two squares? Okay. So I'm going to put two big binomials because we're going to have a couple terms here. So this x squared plus 1, that's going to be at the beginning of each. And I know the x has to be at the end. And then I know I just change the signs. Never used that once in my life. So there you go. That is how you do that. I'm going to do another one. Okay. Okay, so that's a more extensive process. And everyone hated this when I took algebra. We hated it. So I'm assuming a subset of you also don't like it. All right, here we go. Here's another one. All right, again, all I'm going to do as an aside, this, not a part of the problem, although you can show this if you want, if this ever came up on an exam or quiz. You look at the first term, it's x to the fourth. All right, well, its square root is x squared. And how do you take this? What's the square root of 9? 3. Now, because I have a negative sign in front of the middle term, I'm going to make this one negative. And what I'm going to do is I'm going to square it. So I'm going to just make it to look like FOIL. And then go ahead and evaluate this. So I'll have x to the fourth minus 3x squared minus 3x squared plus 9. So then what I'm looking to do is introducing a x to the fourth minus 6x squared plus 9 into my original polynomial. All right, so again, I'm looking to mess with this middle term. All right, so I got a negative 7x squared that I got to split into two terms, right? One of the terms has to be a negative 6x squared, so I'm going to put that one in. I already know that's got to be there. So what does the next term have to be in order for me to make it a negative 7x squared? Because I can't add, like, more than it was already there. Yeah, right? Right, so does negative 6x squared minus x squared give me a negative 7x squared? Sure does, right? And now I'm just going to rearrange. So now look, I have that x to the fourth minus 6x squared plus 9, just like I have over here. So I don't have to worry about how to factor it. I already know what it is. It's x squared minus 3 squared, right? Because that's right up here, this guy here. And then minus the x squared. And again, we have a difference between squares. So when we do this, you're always going to have the difference between two squares. All right, I'll put big sets of parentheses here because we're going to have an x squared minus 3 at the beginning of each. And then an x at the end, and then change the signs. That's it. Okay. You all right with that? Okay, so we're just at the point where we're going to do the quiz. I want to ask, because I do have one more example of, let me just show you. These guys here. Where are they? Nope, I went too far. Yeah, right here. Would you like to see another example of that? Yeah, all right, so I'm gonna do one more example. What I'll do is, I'm just gonna do it on this side so that when you look at the notes, it'll just be an extra one. So I'm gonna do one final example here, and then we'll do this quiz and I'll talk about that. So here we go. Here's one final example. And again, I'll be giving you a homework assignment so we could go over more next week. So 8x squared minus 10x minus 3. All right, so that's what we're doing. So we have to find A. A is 8. C is 3. Now notice I'm ignoring the signs on the negative 3 because I don't care at the moment. So then A times C, 8 times 3 is 24. So this one we can factor easily. We have 24 and 1, 12 and 2. There's a lot of them. 8 and 3, 6 and 4. Is that it? That's it. Oh, this is a good one. Which factor or factors can give you a 10x? So 6 and 4 can do it, right? 12 can do it. So which one is it? Six and 4. Let's try it. So we have 8x squared, and then we're gonna so to split negative 10x, we're gonna do. I'm probably gonna put the 4 first. So negative 4x minus 6x minus 3. So that works. So far, so good. Let's factor by grouping. Oh, that was a terrible parenthesis. So the GCF of this first term, or first pair, should be 4x, right? All right, so to get 8x squared from a 4x, we're going to multiply by 2x, and then we're just going to be minus 1. And then what I'm going to do is I'm going to do a negative 3 on this second pair and get 2x plus 1. Uh-oh. Didn't work, did it? Or did I make a mistake? Didn't work. Okay. But is there another factor that will work? Which one? All right, so that didn't work. All right. Let's try the next ones. So 8x squared. All right, so for 12 and 2, though, I'm going to be doing is the 12 negative or the 2 negative? 12 is going to be negative, so I'm going to do, let's see, minus 12x plus 2x minus 3. And then we'll do our process. So I'm going to take out, looks like I could take out a 4x and be left with a 2x minus 3. And then, again, this is taking out a 1, and then we're left with that 2x minus 3. So we have 4x plus 1 times 2x minus 3. Okay. I'm glad I did that example, because clearly 2 of these factors would have worked. Right? But the 12 and the 2 was the one that ended up being the one we wanted. Okay? Okay, so it's almost quiz time. So that's the end of section P4. So now just by the way, when you go through P4, there's certain things I may not cover, so you're obviously not responsible for those. So for the homework here, so this is P4. So it's on page, I think it's 48. Yep, page 48. All right, I would like 9 to 19 odd, 27 to 33 odd, 37 to 41, 45 to 49, and then 57 to 73 odd. Now, again, just quickly, so 9 to 19, right? This is just using the GCF, okay? Problem type, okay? GCF. 27 to 33, by grouping. 37 to 41, this is x squared plus bx plus c, problem type. 45 to 49, also the ax squared plus bx plus c, problem type. And then 57 to 73, that would be, these are perfect squares, and then the difference between squares. Okay, So I'm even giving you homework that's showing you the types. Like these are the types you need to know for section P4. So master, figure out which ones you know really well. You don't even have to look at them that much, and then focus on the ones that you need to. I'll tell you right now, because I kind of like this process of like maybe quiz on Thursday, collect homework on Tuesday. So I'm going to collect this homework. So we'll do it the same way. I'll have a Dropbox up on D2L. And again, please try to submit one file, right? So like I have a video on how to figure out how to make a PDF, right, of all your solutions. So please try to submit one file, only because if you submit like 10 things, because like there'll be a lot more work for this homework, I don't want to have to open up 10 images. It's just, you're helping me out by submitting one document. I'd appreciate that. Okay, so what I'm going to do is, all right, it's almost quiz time. What I'm going to do is